Developed in the mid-20th century, the shaving cartridge is literally cutting-edge technology. The plastic cartridge can house up to 5 razor blades. This means that shavers can use fewer strokes, which results in a faster, closer shave. And when the blades become dull, they can simply be thrown away. The first cartridge razor was released in 1970. It had a single blade. And ever since then, manufacturers have been racing to add more and more blades in a quest for the perfect shave. Making cartridge blades starts with coiled steel strips that come in rolls that are kilometers long. The strips unwind around guide rollers that orientate them correctly for entry into punch machines. Revolving cylinders help feed the strips to the punches that cut holes in the steel, spacing them at precise intervals. These holes will allow production machinery to grip the steel and move it through the blade-making process. Machinery pulls the steel ribbons through an oven, which heats them to 1,100 degrees Celsius. It then enters a cooling chamber before moving through another oven. The temperature extremes change the steel's molecular structure to make it harder and stronger. The strip is then retracted and then unwound between grinding stones that hone the edge into a very sharp Gothic arch profile. Cameras monitor the strip as it speeds past, and they send images to a computer that can spot any flaws. The steel strip is now ready to be broken into individual blades. A mechanical punch snaps it and breaks it cleanly. With a skewer holding the blades in alignment, a technician scrutinizes the edges for any defects. After applying coatings that prevent rust and add durability, they bake the blades in a furnace. This binds the coatings to the blades. At another station, they mold plastic pellets into the razor cartridges. This machine melts the pellets and injects the liquid plastic into molds as pressure is applied. The plastic solidifies into the shape of razor cartridges. They then bounce along a circular feeder. The feeder turns them front side up, then funnels them into the next machine. This one resembles an octopus with its numerous tentacles. The tentacles are robotic. The first one places the cartridges in a fixture on a revolving table. As the table turns, it serves up the cartridge to the next robot in the assembly line. In quick succession, these robots snap a total of 5 blades into each cartridge. By now, the holes used to move the blades through the assembly process have been trimmed off, so it's a perfect fit. The robots work quickly and with precision. Apart from being fast, the robots can safely handle the sharp blades, so there's no need to worry about cutting your fingers. They now place back casings in front of the cartridges and install pieces of metal on these parts. The metal pieces are sacrificial anodes. Their sole purpose is to be sacrificed to corrosive forces to protect the blades. After that, robots flip the back casings, then transfer them to the cartridge blades and click them into place. The cartridge blades are now fully assembled. The robotic system takes them to a station with more quality control cameras. If no problems are found, the blades move into another mechanized system. This one installs a temporary plastic cover to protect the consumer and keep the blade sharp until it's time for a shave. Robotic arms pick up the clear plastic protectors, 2 at a time, and place them in slots in the assembly machine. They then snap the cartridge blades into the plastic covers. With the protectors in place, the cartridge blades are sent down a chute and into a bin. They're now ready to be sent to the shops and slid over your chops, so you can always be looking sharp.